Hello everyone, welcome to another video on integration. Today I want to look at two questions that involve more advanced cases of u-substitution than what we have looked at so far. So our first question is this one. We're supposed to integrate the integral x plus 4 all over x squared plus 5x plus 6. If you remember, in one of the videos I did talk about a question where in the denominator you had a quadratic function and in the numerator you had a linear function, and I had to work on the numerator to produce the derivative of the denominator. Now in this case here, if you look at the denominator here, this denominator can be factorized, but if you go back and look at that video which I presented, the denominator could not be factorized, so I had to work on the numerator to be able to integrate it, of course using u-substitution. Now in this case, when you look at the denominator here, it can be factorized. And because the denominator can be factorized, I'm going to have to factorize the denominator and then use what we call partial fractions as follows. Let me capture the question first. Two questions only. It tells you that these are quite involving. So let's look at our answer for the first one. Number one, the integral of x plus 4 all over x squared plus 5x plus 6 dx. So like I said, if you look at the denominator, you actually can factorize it. Let me just remind you, maybe it will be too much, but let me just remind you of how you factorize a quadratic expression of this sort. Remember, the technique is x squared plus 5x. I'm going to be a bit quick, plus 6. We're factorizing this. You look at this and that, multiply them, get what is known as product. Let me write it down over here. Get what is known as product. And then here on this side, you have what we call sum, and sum is a middle term. So our sum is positive 5x, and the product of x squared and positive 6x squared is positive 6x. The product of x squared and positive 6 is positive 6x squared. Now you break this one down into factors whose product is this and whose sum is 5x. Now if you check here, obviously you count from 1 into 6, the answer is 6. Because the product is positive, either both 1 and 6 are negative, or both of them are positive. And when you add these up, you get minus 7. Add these up, you get positive 7. From 1, when you're counting, you go to 2. You take 2 into 6, the answer is 3. And because 6 is positive, either both 2 and 3 are negative, or both 2 and 3 are positive. When you add these up, you get minus 5. But when you add these two up, you get positive 5. And that's what we're looking for up there. So I have to put x here and x here and x here, obviously. And this is this one. And therefore, these two terms here must come and replace that term in the center. So I'm coming here and I'm saying this is equal to x squared plus 2x plus 3x and then plus 6 plus 2x plus 3x then plus 6. Now I'm going to perform what is known as grouping terms. So the common factor here, highest common factor, HCF, is x, open brackets. X into x squared is x plus that sign there. X into 2x, 2, close brackets. There, obviously, we have to respect that positive sign there. The HCF of 3x and 6 is 3. 3 into 3x, x. 3 into 6 is 2. So there is your common bracket. Take your common bracket out. And then the other bracket must contain these two terms, x plus 3. So that's the factorization of this trinomial here. So now I can comfortably say that this is equal to the integral of x plus 4 all over x plus 2 and then x plus 3 dx. Now we're going to perform what we call partial fraction decomposition here. Now you notice these two terms are both linear terms. X plus 2 is linear and x plus 3 is also linear. So we're going to say x plus 4. So I'm saying we're now going to look at what we call partial fractions. or partial fraction decomposition. So we have x plus 2 and then x plus 3. This must be equal to, this term here must have its own numerator, which is a all over x plus 2, where a is a constant, plus this one here must have its own numerator, which is, I'm going to say b over x plus 3. Now I must say here that if you have a linear term there, here you must have a constant term as a numerator. If you have a quadratic term, you will see in the next example, you must have, if you have, this part is quadratic, the numerator here is going to be a linear function of the form ax plus b. And then here I would have cx plus d. You'll see it in the next example. But in this case, both this one and this one are linear. So you must have constants there as numerators, separating them like that. Then we're going to perform simple calculation here that says, let's simplify the right hand side. The common denominator obviously is x plus 2 and then x plus 3. The numerator now, we're going to say this into that. These two cancel. If I put this in brackets and this one also, x plus 2 into the denominator, the answer is x plus 3. So I'm going to have to multiply by the numerator. So a x plus 3. And then I have plus here. There is the plus sign. This one into that, the answer is x plus 2 multiplied by b. So b times x plus 2. So what do we have on the left hand side? We have x plus 4 all over x plus 2 and then x plus 3. Now notice that the denominators are the same. It means I can equate numerators because now this is one fraction and that's one fraction. So I'm going to say therefore x plus 4 must be equal to, expand this, I'm going to have ax plus 3a plus bx plus 2b. Now let's collect like terms on the right hand side. So ax plus bx, that term and that term, and then plus 3a plus 2b as a constant term at the end there. Now notice this can be factorized. Factorizing this term here, ax, these two terms, ax plus bx, the answer is x open brackets, a plus b. And then here you just have 3a plus 2b. Let me write x at the end there. So you're going to have a plus b, and then at the end here x, and then plus 3a plus 2b. What is this equal to? X plus 4. X plus 4. Now watch what I'm going to do now here. This is going to be equal to 1 x plus 4. So now what does this mean? I'm going to take the coefficient of x here, equate to the coefficient of x there, and the constant term equate to the constant term there. Form two simultaneous equations and solve them for a and b as follows. So hopefully you can see that. Yes, you can. So now I'm going to say what I have now is therefore a plus b, the answer is 1, and 3a plus 2b, the answer is 4. 3a plus 2b, the answer is 4. Call this equation 1 and call this equation number 2. Now we're solving these two equations simultaneously. Let's see. So we have a plus b equals 1, and then we have 3a plus 2b equals 4. Now I want to eliminate b first. So my coefficient here is 2. I'm going to have to multiply the whole of that equation by 2. So that changes, that equation changes to 2a plus 2b equals 2. The second one here remains 3a plus 2b equals 4. What do I do next? I subtract. So 2a minus 3a, I'm subtracting the whole of the equation, the second equation from the top one. 2a minus 3a, the answer is minus a. 2b minus 2b, the answer is 0. 2 minus 4, the answer is minus, oh, so this is 2, yeah, multiply that by 2. So the answer here is, if you check, the answer is minus 2. 2 minus 4 is minus 2. Now I have to divide by minus 1 both sides. I'm going to get a equals 2. Now that I know what the value of a is, I must come back either here or there to determine the value of b. So I'm going to take the first one here because it's easier. But we know that a plus b equals 1. This number here must come there. So we have 2 now plus b equals 1. And what is b equal to? b equals 1 minus 2, the answer is minus 1. Now notice something here now. We come back, a is 2, b is minus 1. We come back and put 2 there and minus 1 there. So now we're going to say, therefore, x plus 4 all over x squared plus 5x plus 6. We factorized this into that form there. Notice we factorized this expression underneath there into x plus 2 and x plus 3. So we're going to say this is the same as x plus 4 all over x plus 2 and then x plus 3, and this simplifies to 2 all over x plus 2, and then I'm going to say plus minus 1 all over x plus 3. That's how it simplifies. Let's go back to our integration. We're coming back here now and we're changing that form now, or this form, into two integrals, as I will show you on page number 3 here. On the next page now, I'm going to say, if you can see it, I'm going to show you just now. We're going to say, therefore, our integral, which is actually x plus 4 all over x squared plus 5x plus 6 dx, this integral changes to the integral of, open brackets. Remember, our fractions now are 2 over x plus 2, and then this one here, plus times minus, it will just be minus 1 over x plus 3. So I have 2 over x plus 2, then minus 1 over x plus 3 dx. And I distribute the integral sign, and the dx, what do I get? What I get is the following: integral of 2 over x plus 2 dx minus, watch this, the integral of 1 over x plus 3 dx. Now I can take the 2 out because 2 is a constant. So I have 2, the integral of 1 over x plus 2 dx minus the integral of 1 over x plus 3 dx. Now I'm going to have to integrate both this one and this one here. So u-substitution coming in now. So I'm going to now watch this, because I have two integrals here. I'm going to let u1 be equal to x plus 2, and I differentiate. So du1, the answer is equal to dx. You follow what I mean? Differentiate this, du1 over dx, or du1 dx is equal to 1, because derivative of 2 is 0, 2 is a constant. So if du1 over dx, du1 over dx is equal to 1, it means if you multiply both sides by, let me just show you here what I mean. We are having here u1 is equal to x plus 2. So we are saying, what is du1 over dx? The answer is derivative of x is 1. Derivative of 2 is 0. Now multiply both sides by this. Like so. du1 over dx times dx, the answer will be equal to 1 times dx. And these cancel. So what do you have? You now have du1 equals dx. This is what I was talking about, and that's what I'm showing you now. So this is what we get. And let's come this side now. We're going to say u2 is equal to x plus 3. And then we're also going to say du2 equals dx. Now we're coming back into these two integrals here now. We're going to say that one therefore changes to 2, the integral of 1 over, notice, u1, and then dx. Remember here, our dx now must become du1, because dx equals du1. So du1, and then we have minus there, minus the integral of 1 over u2, and then du2. Now, what is the integral of 1 over u1? The answer is natural log. So this is 2 natural log of u1. You don't have to put, we can actually put absolute value signs. And then we have minus. The integral of this is just natural log of u2. And we have to say plus c. And let's put these two guys back in. Now, applying, maybe before we do, let's do it straight away. So this is going to be equal to 2 natural log of what is u1. Notice here, u1 is x plus 2. So we go back to our original variable provided, x plus 2, like this, minus natural log of what is u2. u2 is x plus 3. So natural log of x plus 3 plus c. Now I want to simplify this using laws of logs. Because there's a 2 there, it must come as a power. I'm going to show you just now. So these are quite advanced cases of u-substitution. We had to do partial fractions first, and then we're coming here now. So this should be equal to, I think I have enough space here. I'll bring it down like so. All right. So this should be equal to, please take note of that. This should be equal to, this part here is going to be natural log of, and because the 2 now will become a power of this, I can use round brackets now, x plus 2 to the power 2, because that can never be negative, right? It can never be negative. And of course, we're assuming that x is greater than, x is not equal to minus 2, I should say, because if x equals minus 2, this becomes 0, and natural log of 0 is undefined. All right, so here we're going to say minus natural log of, watch this, still having absolute value signs, because this can be negative, like so, plus c. Now, laws of logs, which law did I apply here? I applied the law that says p log of m is equal to log of m power p. Now you can remove the log and put natural log. It's the same thing. Let me just show you on another page here. This log here is what students are used to, but we know that we can also say natural log p natural log of m. The answer is the same as natural log of m to the power p. So this form here is that form there, and we need this form here for us to be able to simplify it. So proceeding, we're going to say this is equal to, I'm going to apply another law of logs now. So this is going to be natural log of, because it's a minus here, it means these two must divide as follows: x plus 2 all squared all over x plus 3. Now notice something. Now I must have absolute value signs because of the denominator. It can't be negative, that because there is no square, so it can be negative. And then I'm going to say plus c. So this should be the final solution to our integral. Now, not very friendly, but you'll understand what I'm trying to put across. Very simple. Maybe I should say the simpler of the two, because this is quite simple. The second one is not this kind, right? So let's move to the second one now then for today. The second question for today is this one here. And I'm going to, so this is what we've done so far. We've looked at this one. Notice what I said earlier on. In the previous video, I had to work on the numerator, because if you differentiate this, in this case, it will be 2x plus 5. And if you change that to 2x plus 5, there's no way of changing that to 2x plus 5 because of this 4 here, because you would need a 2 there. And for you to have a 2 there, you'd have to multiply the whole of this by 2. So that would be 2x plus 8. But then you have a 4, so you have to get rid of that. Obviously, you're going to divide by 2 there. But 8, you'll have to write 5 plus 3. You see, the 3 will have to be over that. So you'll have to use what we call trigonometric substitutions, which would make the problem more complicated, because then you would have to complete the square of the denominator there. And with 5 here, it would be horrible to complete the square of that. So the easier one is partial fraction decomposition. And obviously, we're using u-substitution as well. But the second one, this one here, is an MIT integral. And this is a giant. I want you to pause the video and attempt this question, and you will see how involving the question is. Differentiating the denominator, obviously, you'll see here you have 4x cubed plus 2x. And there is no way you can find x, you can make x cubed in the numerator. So this one here is one of those MIT, if you have watched MIT Integration B type of questions, extremely involving. If this were to come in your exam, calculus 2 or calculus 1, it would have to be 20 marks. Now that is quite something. So let's look at this. And I'll surprise you to say that the reason why this one looks very difficult is because the kind of mathematics involved here is simple algebra from grade 10. And not many people still remember simple algebra from grade 10. So I want to show you now. So this is how we set out the solution. Now, this is question number 2. Question number 2, it says here the integral of x squared minus 1 all over x to the power 4 plus x squared plus 1 dx. Now, I want to take you back to grade 10 algebra just a little bit so that you follow what I'm going to say here. If I take you to grade 10 algebra, this is what I'm trying to say. You remember even on this channel, I've given you some work on algebra. If you go back there and check, you'll see the explanation I've given for stuff like a plus b all squared. We said, let me use a different pen here because this is quite faint. So we said a plus b all squared. I've said to you that the way you expand this is you take a multiplied by itself, it will be a squared. Take a multiplied by b, it will be ab. Double that. And if the sign is plus there, put a plus sign here. If it's minus, you must have a minus sign there. And then the last term here, which is a positive b, it doesn't matter whether it's positive b or negative b. When you multiply that by itself, it will always be that squared. Now, if you look at this term here, has some kind of similarity to that. Especially if I say this, if I say, suppose you have x squared plus x plus 1. Now you notice, for you to obtain this, you would have to set x, a be equal to x. So that would be x. And then here, there's a 2 there. But here there's a 1. The reason why I'm leaving a 1 here, because if you look at this one here, there's a 1 there. So it has some similarity to this. So what I'm going to do, when I have this and I'm required to factorize in grade 10, remember if your teacher told you to factorize this, what did you do in grade 10? What you did was you said, this one here tells me that the only way I can factorize this properly is when I have x squared plus 2x plus 1. And if you have this form, you know you have that form where x equals a and obviously b equals 1. If you put x equals a here, put a equals x there, put x there, it will be x squared. B equals 1, this will be 2x plus 1 squared is 1. Now, there is something in common between these two. To obtain this one from this one, all I have to do is just subtract x. Now, so if they say I must factorize this, then I know this is what I have. And this is a perfect square because this is just x plus 1 all squared. And then I have minus x. And if I want to force this to be difference of two squares, I'm going to say square root of x and I square it because I know square root of x squared is x. Then now I can say, all right, what do we know about difference of two squares? Well, we know that if I move up, we know that if you have this, the answer is going to be a plus b, a minus b. So that means if I'm required to factorize this, I'm going to have x plus 1 plus square root of x plus 1 plus square root of x in one bracket. And then in another bracket, I'm going to have x plus 1 minus square root of x. That is factorization of this expression here. You get this. You can expand this. It's going to give you that. So this is the kind of trick that is hidden here. So what we're going to do now is to say this is equal to the integral of x squared minus 1 all over, watch this, x power 4 plus 2 x squared plus 1, and then I'm going to say minus x squared dx. There is a moment of brilliance right there. Now, this can be factorized now because there's x power 4 and x squared here. We know that this can be factorized to x squared minus 1 all over this one here. This changes to x squared plus 1 all squared. And then I have minus x squared. There is your difference of two squares in the denominator. So what do I get? In my next step, I'm going to have x squared minus 1 all over this part here minus x. So x squared plus 1 minus x. Or if you want, you can say plus x. It doesn't matter. In the other bracket, you must have a plus. So remember, a squared minus b squared, it will be a minus b, and then another bracket a plus b. So here I'm going to have x squared plus 1 and then plus x in another bracket dx. Please expand this and you should be able to get that expression there if you expand this one. Right, let's rewrite it now in standard form. So we have x squared minus 1 all over. This one here can be written as x squared minus x plus 1 in one bracket. And this one can be written as x squared plus x minus 1. And then I have dx there. There you have it. Now we have quadratic term multiplying. Let me just quickly go through this so you see that when you expand this, the answer actually is that. Let's just do a simple algebra here, expansion of that expression as quickly as we can. I know we're dragging time there, but let's just do it so that at least everyone is happy. I'm saying you have x squared minus x plus 1, multiplying this by x squared plus x minus 1. This one here, remember what we say? This term, x squared, must multiply by the whole thing. X squared plus x. At the end there is supposed to be plus 1. So it's plus at the end there is always plus 1 because we have, remember, this is plus 1, there's plus 1. So it must be plus 1 there like this. Yeah. So x plus 1 like this. And then you have another bracket. Remember, this must multiply the whole thing. And then we have minus x must multiply again the whole thing plus x plus 1. And then finally we have 1 must multiply the whole thing. So we have plus 1 multiplied by x squared plus x plus 1. Now let's expand this times that. What do we get? X squared times x squared is x power 4. X squared times x is x cubed. X squared times 1 is x squared. And then we're here. Minus x times x squared is minus x cubed. Minus x times positive x is minus x squared. Minus x times positive 1 is minus x. And I'm here now. 1 times the whole of that expression is just going to be x squared plus x plus 1. Now watch something here. Watch something. This term cancels that term. That term cancels that term. And that term there cancels that term. So what are you having left in the denominator? X power 4. And then that term there, x squared. And then the last one there, plus 1. So it simplifies back to the original expression. So let's carry on then. Now, what we're going to do next is to decompose this one using partial fractions. Now, here is the next step. So now we're going to say x squared minus 1 all over x squared minus x plus 1 and open brackets x squared plus x plus 1. This is going to be equal to, remember this is quadratic and that's quadratic. Now I'm going to say ax plus b all over this expression x squared minus x plus 1. And then I'm going to say plus. The next term is going to be cx plus d all over this part. So it will be x squared plus x plus 1. Now I'm going to do what I did in example number 1. Now let me move backwards because this will not change. But that one, the common denominator there is going to be x squared minus x plus 1. And then you have x squared plus x plus 1. And then we're going to say this expression here into that. The answer is this one here because these two cancel. Remember, that's the denominator. So this cancels that. You're left with this. This has to multiply with the numerator there. So I have ax plus b times x squared plus x plus 1. Then I must continue this expression here now, dividing in there. These two cancel. I'm left with this one. So I'm going to say plus that plus sign. So it will be cx plus d multiplied by, in that space there, I'm going to have this, which is, if I may put it down here, x squared minus x plus 1. It must come into that space there. Right, so now denominator here is the same as denominator there. It means I can equate numerators. So x squared minus 1 must be equal to this expression here. Let me stretch it over here. Please don't give up. You see how the solution comes out. Solution will be very nice. So now what we have is, I told you, denominator are the same. So we're going to equate the numerator. So that numerator there must be equal to that. So we're now saying x squared minus 1 must be equal to this part here, ax plus b times x squared plus x plus 1. And then I'm going to say plus cx plus d times x squared minus x plus 1, like that. Now we have to expand this. So we have to say ax times that, it will be a x cubed, that one. And then we're going to take the same one, multiply there. It will be plus ax squared. And then ax times 1, it will be plus ax. And then I'm coming with b now. B times ax squared, b times x squared, it will be plus b x squared. B times x, it will be plus bx. Yeah, this x here is not looking very nice. I just want to clean up a little bit, and then we move forward. Right there, the x must be very clear. So let me repeat. I said ax times x squared is ax cubed. Ax times x is ax squared. Ax times 1 is ax. And then b times x squared, bx squared. B times x, bx. B times 1 is b. We're done with the first bracket. Now we're coming here. Cx times x squared is cx. Remember now, it's a plus sign. There it is. So I'm going to say plus there. So cx times x squared is cx cubed. Cx times minus x, the answer is minus cx squared. Cx times positive 1 is positive cx. And then I have to go to d now. D times x squared is positive dx squared. D times minus x is minus dx. D times 1 is positive d. Now we're going to put like terms together. That one and that one are like terms. So now I'm going to say that will be equal to, and if I factorize it, it will be a plus c in brackets x cubed. I'm done with these two terms. Now I'm moving to terms containing x squared. It will be that one, and that one, and that one finally. So it will be a plus b minus c plus d. So plus a plus b minus c plus d, and I have outside x squared. Now I'm moving on to terms containing x. So plus, which terms containing x? Contain x. It's that one, number 1, number 2, number 3, and number 4. So it's a plus b plus c minus d with x outside. So a plus b plus c minus d, and then I have x outside. And two constant terms are b plus d. So plus b plus d. Now notice where we're coming from. We're coming from x squared minus 1. So if I rewrite this, I'm gonna have in that space, I'm gonna stretch it up there because I need more space. I'm gonna have 0x cubed plus 1x squared plus 0x and then minus 1 to have it in standard form. Why am I doing that? Because I want to equate coefficients. So a plus c must be equal to 0, and then a plus b plus c, a plus b minus c plus d must be equal to 1, and then I'm going to say a plus b plus c minus d equals 0, and finally b plus d equals minus 1. And I solve those equations simultaneously. Let's move to the next stage. I told you this question is an elephant. Let's go to the next stage. So now what am I saying? I'm saying, if you check in this equation here, let's pick them slowly. I said to you that a plus c must be 0. So equation number 1, a plus c equals 0. Equation number 1. Let me pick the next part. The next part is a plus b, a plus b, a plus b, and then minus c plus d is equal to coefficient of x squared on the left hand side is 1, is equal to 1. equation number 2. Let's go to the terms containing x now. It's a plus b plus c minus d. A plus b plus c minus d is equal to 0. The coefficient of x on the left is 0. Equation number 3. And then equation number 4 will be the constant term now, which is b plus d equals, what is the constant term on the left? Minus 1. So that's equation number 4. Now, these equations are very nice and simple to solve. One may easily give up, but watch what happens next. If I pick this equation here, it has b plus d, which is minus 1. So now I have a minus c, if you like, plus b plus d equals 1. I'm rewriting, I'm putting these two together. But what is b plus d? Is minus 1. So I'm going to take minus 1, put here. So I have a minus c minus 1 equals 1. What is a minus c equal to? Take 1 the other side, it adds. This is equation number 5. Now pick this equation and that equation. Let's solve them simultaneously. So we're going to say a plus c equals 0, and then a minus c equals 2. When we add these equations up, this is 2a, c, positive c minus c, the answer is 0, and on the right I just have 2. Look at how simple that equation is. Divide both sides by 2, you get a equals 1. Right, first solution obtained. Now if a is 1, it means we can now find the value of c. Let's go here now. Moving up, I'm going to move these pages down a little bit so you are able to see. So we are here. So we are now saying, here you can see. So we're now saying, if you check this equation here, it says a minus c equals 2. And up there it says a plus c 0, a plus c 0. But we found a to be 1. So I'm going to put 1 there and say plus c equals 0. So I'm going to say a plus c equals 0, and a is 1 plus c equals 0. What does this give us? It gives us c equals minus 1. Now, watch what happens now. We know a is 1, c is minus 1. Come into this equation which we haven't used. A is 1, c is minus 1. Put them there. So what are we having now? A plus, here it says a plus b plus c minus d equals 0. So we're saying a plus b plus c minus d equals 0. What is a? 1 plus b. What is c? Minus 1 minus d equals 0. You see that these cancel? Yeah, so b minus d equals what? This is equation number 6. Now look at this equation and this equation here. We can solve for b and d there by simply adding them. So I'm going to say b plus d. This says equals minus 1. Equation number 4 there, minus 1. And here we have b minus d equals 0. Let's add these up. B plus b, 2b. When you add these up, the answer is 0. Minus 1 plus 0 is minus 1. Divide both sides by 2, b equals minus half. And if b equals minus half, you can come back here and obtain d. Put minus, or even here it's better. So we're now saying, I'm taking this number and I'm placing it in that place. So I'm going to have minus half minus d equals 0. Just take d to the other side. You're going to have minus half equals d. So now we have all the the constants obtained. So we go back to our start. Remember, a is 1, c is minus 1, b equals d equals minus half. Let's go back to our original page. There's our original page there. Now I'm going to come back here and I say a is 1, b is minus half, remember. C is minus 1, d is minus half. So now it means our integral changes as follows. Now it means we're going to say, therefore, x squared minus 1, which is all over x squared minus x plus 1 times x squared plus x plus 1. This simplifies now to, remember, a is 1, b is minus half. So I'm going to have x minus half. Yeah, and then I have all over x squared minus x plus 1. And then the other part will be plus. Remember, c is minus 1 and d is minus half. So minus 1x minus half all over x squared plus x plus 1. Now let's simplify this. I'm moving it down here, this side. So now I have x minus half all over x squared minus x plus 1. And then the minus here, I'm going to factorize in the numerator there. Take the minus 1 out. You are going to have minus, if you agree with me. And then up there, I'm going to have x plus half all over x squared plus x plus 1. So this is how it simplifies to. So now I can say quickly, I'm way beyond my time. So now I can say, therefore, my integral, which is x squared minus 1 all over x power 4 plus x squared plus 1 dx. This simplifies to now, watch, the integral of, open brackets, and I have x minus half all over x squared minus x plus 1. And then I have minus x plus half all over x squared plus x plus 1. And then I have dx. Distribute this one and that one there, the integral and the dx. You're going to get something like this. Integral of x minus half all over x squared minus x plus 1 dx. And then you're going to say minus the integral of x plus half all over x squared plus x plus 1 dx. Now this is beautiful, because what I'm going to do now is multiply the numerator there. That trick comes up again. I'm going to multiply the numerator by 2, divide by 2, multiply by 2, divide by 2. And watch how beautifully this solution comes out. So now we're going to say, if I have it in that space, moving it to the left a little bit, but it doesn't come out of view. So this is going to be, watch this, I'm going to say half of the integral of 2 open brackets x minus half all over x squared minus x plus 1 dx. And then I'm going to say minus half the integral of 2x plus half all over, hopefully you can see these numbers clearly, x squared plus x plus 1 dx. Now expand the numerator there. What you're going to get, if I may be allowed to use another pen here now, what you're going to get is the following. You're going to get, hopefully this can be seen, you're going to get the following. Now that's not very nice. Let me go back to my markers. So you're going to get that times x. So this is half the integral of 2x minus 1. If you notice, 2 times minus half is minus 1. And I have x squared minus x plus 1 dx minus half the integral of, expand that out, 2 times x is 2x, 2 times half is positive 1 all over x squared plus x plus 1 dx. Now watch the u substitution coming up. Now I'm going to let u, this part, if you like, u1 be equal to x squared minus x plus 1. What is du1? Equals 2x minus 1, differentiating this with respect to x, and just put dx there. Let's come this side. u2 equals the denominator, which is x squared plus x plus 1. What is du2? You'll agree with me. This is 2x plus 1 dx. Let me write dx there. All right, there is dx. Now I'm going to take this one. It must come. Remember that numerator now. 2x minus 1 dx is actually du1. So this one then changes to half the integral of 1 over u1 du1. And then I have minus here. Minus half the integral of, combine this one and dx again, and you're going to have du2. So you're going to have 1 all over this. 1 over, what is this? It's u2. u2 du2. Now this is half natural log of u1. For the sake of time, allow me not to put absolute value signs there. Minus half. I'm forced somehow to put absolute value signs. Let me do that. Minus half, and then this is going to be natural log of u2. And then I must say plus c, because I'm dealing with an indefinite integral. Now let's get back to our original variables. So what is u1? It's this one here. What is u2? It's that one there. And because of these halves here, I'm not going to check whether they can be positive or negative. You'll see what those halves do. So our final solution then is going to be, are you okay? I'm still in a space where you can easily see what I'm writing. So this is going to be, watch, half natural log of, and here I'm going to have x squared minus x plus 1 minus half natural log of x squared plus x plus 1, and then plus c. Using laws of logs, the half must come there. Again, that same law that says m, natural log of m power p equals p natural log of m. So this form here is that form there, and I want this form. So the half must come there. So that means this will change to natural log of x squared minus x plus 1 to the power half, and then minus natural log of x squared minus plus x plus 1 to the power half. And what is the power half? Of course, plus c. Power half means square root. So this is going to be natural log of square root of x squared minus x plus 1. Now you understand square root can never be negative. So especially we're dealing with real numbers. Now this changes also to natural log of square root of x squared plus x plus 1, and then plus c as a constant there. Using laws of logs again, because of my subtraction here, these two must divide. So we're going to have natural log of square root of x squared minus x plus 1 all over square root of x squared plus x plus 1. And I'm going to have, let me keep, I don't have to put this because these expressions are positive all the time. I don't have to put absolute value signs here. So let me just use brackets like so. And then I'm going to say plus c. Now, this is the final solution. Now you tell me what kind of question this is. We are 47 minutes, just over 47 minutes, just 2 questions. This is the story of the advanced applications of u-Substitution. Now, if you are not patient, you would have given up already somewhere up there. You throw in a towel and say, nah, this is not for me. But if you are someone who appreciates mathematics and you don't give up, this is for you. And the attitude towards scoring very high marks in maths, statistics, physics, chemistry is to be persistent. If you know what you're doing is right, keep going. Keep going, and sometimes the answer comes out as simple and nice as it looks here. All right, I'm going to stop here. If you're new to the channel, please subscribe, support us. We actually appreciate your feedback. Give us comments and say something about this question, and let's see what you're thinking about it. There are many more complex cases of this nature, some of them even harder than this one. That would take 60 minutes for me to answer it and explain it like I'm doing now. So if you are used to scoring, getting those questions, you understand that there can be no exam that will give you headache at all. All right, see you next time. God bless.